Okay, welcome to sort of a crash course on basically a virtual wind tunnel analysis using AIM. So let's look for the icon that looks like this, ANSYS AIM 18.2. If you have a different version, it's okay. It should be very similar. This is definitely a crash course. There's lots of stuff I'm going over very quickly. The idea is to give you enough so you could repeat what I'm doing, and then we'll come back and spend more time and talk about the details of anything that we've sort of glossed over. So you got to be patient with this. The idea is to get you using the simulation software, even if it's a little bit confusing and hard to understand at first, because we're going to come back to it later on in the year. When when ANSYS AIM opens, there's several different options that you can use. By hovering over these panels, you can read up on what it is that, what type of simulation is taking place. A wind tunnel is fluid flow, so we're gonna go straight to the fluid flow panel and hit the start button. The way AIM works is we basically follow this thing called a workflow that you'll see develop down here as we start to answer these questions and fill out the form. So we're going to just use a lot of the defaults right now. We're gonna import a geometry file that we had already built, and let's just keep all the defaults right now and hit next when that comes up. And we're going to point to the model that I'm talking about. We have something called basic shapes that should have downloaded by now. So let's just select basic shapes and say open, and give AIM a minute. It's got to generate some of the background stuff that we need to run the simulation, including the CAD engine and all that sort of stuff. So a lot of times you'll see this progress bar down here with a percent complete, depending on what task is taking place. And when that happens, you'll see the geometry, and we'll talk about this in a second. Again, we're going to just use defaults right here. We're using a static type of analysis, and we're not going to turn any of these additional flow physics on yet. They could definitely be important depending on what we're trying to do. We're just not going to worry about it right now. So let's just say finish, and you can see the progress bar is moving along as some of these additional elements kind of come into place here. So we're going to work through all of these, the geometry phase, the mesh phase, solving the physics, and then looking at the results to be able to help make decisions about how to optimize shapes of car designs that we're going to be converging on in the next few weeks or months to be able to get the most fuel efficient automobile design that we can come up with. So the way this works is that you can basically select on any of these elements here. So the first thing I want to do is I want to go over this geometry a little bit and discuss the things that we're going to be including in the simulation and things that we're not. So let's go. If I hit the geometry button, this panel comes up and I get this option of saying edit geometry. You'll see a slightly different view here. I'm just going to close that right now. So this is what our geometry looks like. There are three things that are right on top of each other, and these are basically three shapes that are going to have very different aerodynamic performances, right? One is just the basic brick. That was the thing that you saw just previously because it was encompassing pretty much everything. And if I look at my geometry here, I can see all different objects as I highlight over them. I can also disable them here. At least disable the view just by toggling them off. I'll be left with whatever objects are remaining. In this case, we're actually going to look at the car body. Okay, so I enable the car. What we actually want to simulate in AIM is the enclosure. So if we're going to build a wind tunnel, we need the box around the object to be the wind tunnel, and then the fluid flow is going to be solved all around this object. That's what we're trying to do here. So the way we do that is notice we're in the design tab right here. We're going to go over to the prepare tab and look for this thing called enclosure. So when I select that, the instructions are to select the bodies that I want to create an enclosure around. I only have one visible, so that's the one, and I'm just going to accept the defaults again. It basically gave me a box of air around that geometry. So when I hit the check mark, this is what I have now. So the last thing we're going to do is I'm going to disable so there's a difference between visualizing and disabling for the analysis. So what I want to do is right click each one of these and say suppress for physics. And notice the little no sign shows up on the car. It's also going to show up for the brick. It's also going to show up for the rocket head. So if I turn the view off and they're also disabled. The only thing left is the enclosure. So why are these faces here? It's because the enclosure is surrounding that object. So it's as if there's a complete solid behind all those faces. So we ultimately have the shell and the air around it, and everything inside of that body is the solid. So that's what we wanted for this analysis. So that's the process for getting basically the wind tunnel brick that we're going to analyze inside AIM. So with all that done, you can do that on any geometry you have. I'm going to hit the X mark up here, which brings us back into AIM. It's going to go through the update right now, and you'll see things have changed there. So that brick disappeared, and now it's replaced with the enclosure itself. Okay, a couple things that are going to be important here. Notice these little icons. If you hover over them, these are different selection modes. If I want to select faces or entire bodies, right now you're looking at the entire body, and I can basically turn things on and off by right-clicking in space here. I can say, well, in this example, I'm going to choose the face. Okay, so I selected the face, the whole thing highlighted, and if I right-click, I can say hide face, and what you see in here are the additional faces. So that's good. That's exactly what we wanted. That's the enclosure and the solid that's sitting inside of it. So that's good. I can go back to the empty space, and I can always say show all, and my solid comes back up. Okay, so we'll be going back and forth between that. My geometry window is clear. Everything looks good there. I'm going to go to mesh now. Okay, we'll talk about that in detail later. But when I go to mesh, basically this is chopping up my geometry into small segments that are going to be solved. We're gonna be okay with all these defaults, but there's a mesh control that I'm basically getting a warning here. So I'm going to click that mesh controls, and the one that is a concern is this thing called boundary layer. It's telling me that it needs to know what those boundary layers are. So the way we do that is we go into it, and for location here, it wants me to define the faces of the boundary of where the vehicle is going to be. So to get there, I'm going to first right click. I'm going to select this face and right click and say hide the face for now. I have to come turn it back on later. And if I get my view right, I can do a rubber band, or I can do a box select of just these faces. So nothing on the wind tunnel boundaries itself. And notice when I do that, it looks like I got everything I wanted. Okay, and it still says undefined because the objects are highlighted orange here, which means they're ready to be added. So if I hit the plus, 20 faces came in, and that's the amount of faces. All of this makes sense. That's the exact amount of faces. If you were to count them up, you'd see 20 of them. So that warning has gone away. So we're just going to go back to the mesh. I can do it a couple of ways. I'll just go back up here, and it says out of date. So let's just generate the mesh. Give it a second. You'll notice the progress bar is moving along as it should, and it's actually chopping up that geometry into tiny chunks so that it can apply the solutions to it when the computer starts cranking away. So we'll give that a second. So when it's done, you'll get something like this. So this is just basically showing you the surface of those mesh elements. Turns out the volume is just included, the entire volume is chopped up into basically those same triangular elements. Okay, but as you zoom in, you can see the elements get really small around the edges, as you would expect. We'll talk about mesh and how important it is in a solution later. Right now, we just want to get through the process of setting everything up. So that looks good. With that, we're going to go to the next step now, which is physics. So let's just click on that brick, and it tells us that there's attention required in a few areas here. The first thing is going to be fluid flow conditions. So it's blue. It means that we need to define some things here. So let's do it this way. Before we get into this, remember I hid one of those faces. It's going to be important to turn that back on. And you can see it's not highlighting here, but when I go to right click and I say show all, that face came back up. That's good. That means I can select every face in my geometry right now, which is where these fluid flow conditions have to take place. So let's just start. Let's start, instead of adding them here, we're just going to do a lot of right clicks in the space here. So I want the fluid flow to come in from the Z direction in. So if you look down here at the compass, it tells you what direction is which. I want the fluid flow to come in as if it's coming from the point of that arrow into the negative direction, so backwards. Okay, so if I highlight that face and right click, I can say add fluid flow condition. We'll call this an inlet. It brings up a new form. I can either fill it out on the left over here, or now that I have this form right in front of me, I can give it what it wants. It wants a velocity magnitude right now. Let's say 5 meters per second. If I just say 5 and enter, then that condition has been met. Remember, I have to put a condition on every one of these faces. There's 20 faces representing the car body, and there's 6 faces representing the wind tunnel. So I just got one of the 6 for the wind tunnel. If I left click on the other face, on the far end of the inlet, I can say add fluid flow conditions, and I'll call this one an outlet. That's where I want the wind and the wind tunnel to exit. And in this case, it wants a gauge static pressure. I'm just going to give it 0. Okay, and I met that condition. Now there's a trick here. I want to give the sides of the wind tunnel a boundary condition, as well as the surface of the car body itself. So if I get the view so that I can avoid selecting the inlet and the outlet face, but I can select everything else, one little trick is that instead of doing a selection this way, I can do a selection this way. And as long as I enclose all of those faces and get all 4 sides of the wind tunnel, they all get highlighted. And with them highlighted, I can now right click on any one of them and say add, and I'll go to fluid flow condition again, and this time I'm going to give it a condition called wall. And it is what it sounds like. It's not going to let anything go through there. We're not going to worry about any other options here. If we look at physics, those warnings, the red, I think if we had a red warning there earlier, it's certainly gone away now. I've got the appropriate boundary conditions set up everywhere. There's a couple of other things that are going to make your solution go a lot faster, so these are also important. And if I go to solver options down here, I can say solver settings first, and the number of processors on the computers that you're most likely using should be 4. So your solution will go faster if you say 4. And let's apply that. Give that a second to apply. And again, we're trying to get simulations to take place as fast as they can while still preserving accuracy. But if you've got a number of processors available, you should be using all of them. So with that done, I can come back to solver options and I can say solution controls. We'll talk about the maximum number of iterations in more detail later. But the way a computer solver works is that it's gonna compute the solution multiple times and compare and make decisions on when it thinks it's done. Okay, and 1,000 iterations is a good number usually. We're gonna just ratchet that down to something that's gonna solve faster. Okay, and we can always come back and fix that. So let's just change it to 25 for now. And with that done, I can see, let's do it this way. I can just go back to my physics panel here, and I'm going to say solve physics, and we're going to let it go. Feel free. I'm going to pause while the solution is taking place, but feel free to open up solution monitors and transcript and messages. You can see what's taking place. I like to leave it on solution monitors, and you'll start to see that populate with basically a trend, a chart that we can talk about. So I'm gonna hit solve physics, and I'll come back when the solution is done. But look in the progress bar and look at what happens here. This might take you anywhere from 5 to 10 minutes, depending on if you followed all these steps and depending on your computer. Okay, so we'll be right back. So if you end up with a message that looks like this, it's okay. It's just telling you that the solution is not as accurate as it could be. But the price that you pay for an accurate solution is waiting for more, waiting longer for it to solve. You should also see something similar to this for your iterations. Okay, and we stopped on 25 because we told it to. Again, we'll come back and talk about that at some other time. But for now, all that should look normal. And you'll see that the results tab now is the one that needs to be updated. So that's good. That's where we want to be. That means that we have something actually to look at. So we could start just by, we could just actually say evaluate results and not worry about the details and let's just see what it looks like. So there's one object. It's going to be called result 1, and if I don't look at anything and I just say evaluate results and I hit the button, let's see what updates. And you can see it's working on something down here. Okay, so when that's done, I think I actually have to select the object. Yeah, there we go. So when I select the object itself that results, I can actually see them, right? So it's telling me this must have been a velocity result, right? I can see it applied to the volume, the entire enclosure. The variable was velocity, and here's some other settings. And what we're really looking for is the visualization here. I can see the result of injecting airflow on this side at 5 meters per second, and I can see how the individual velocities change as it has to interact with that geometry. And that's what you see. Basically the air is moving around that object, and you can see much smaller velocities. And I can look at the color of those arrows as I zoom in and see different colors of the arrows. I can see the blue here must be these small amounts, much slower flow, whereas going up above the surface is a lot higher. Okay, and it's also telling me what my max, my fastest and my slowest velocity would be. So that's good. And what we can do is we can keep coming back to this results tab and add as many of these different types of results as we want. So I'm going to go, let's just select results here. And back at this panel, there's a few ways to do it. One thing I wanted to do first, though, was look at, well, actually, now that we're here, maybe we'll just do some more contours right now. So let's do it this way. Let's try to add a, let's see if we can do this. Try to add a contour, okay? And for the location, I'm going to right click. No, actually, let's do it this way. Let's I think from my location here, it wants a 2D geometry. Let me back up. Let me back up here, and I'll delete this. I'll delete this result. And that's okay. I still have my velocity results, so I undid the thing that I was trying to do. I'm going to right click on, I'm going to first left click on that face of my enclosure. I'm going to say hide the face, and let's right click on this. Once I select it and I right click, I can say add, I can say a results contour here, okay? And I can, on that face, look at the differences in pressure by evaluating that result. So let's see what happens. And there it is. So I can see my min and max pressure that's associated on that face. I can do the same thing with this face. Actually, if I have to go back to results, notice I've got two different results to look at now. I'm going to add a new one. I'm going to grab this face and look at the pressure on this. And I can say add results, and I can do a contour plot on that. And actually, instead of pressure, let's look at force. We'll look at force magnitude, and I'll say evaluate that. And I can see the distributions of force. And I'm getting the largest amount of force up here on the top of that surface. Okay, so you can continue to explore these different results. And the one thing that I think is really important is that we have a way to just get everything down to kind of one number. So we're going to be looking at multiple body variations for the automobile, and they're going to change quite a bit. So one way to quantify how good the aerodynamic performance is if we can just look at something that's related to the entire drag of that object. So the way we'll do that is that, notice that my enclosure face right here has been turned off, so we can't see it. So I'm going to select all of these faces for my automobile. And if I right click this, I can say add a result, but instead of doing one of these planar results, I'm going to use something called calculated value. It found 20 faces. The function I'm going to use is going to be a summation. The weight type, let's just use something called simple for now, and the variable is going to be, instead of velocity, I'm going to use force. So if I expand force, I can look at the force magnitude, or I could look at the force. I'm going to try to make it easy by saying force in the z direction. Remember, the z direction is the direction in which the airflow is coming. The airflow is actually coming in the negative z direction, and that's because we define it that way. So if I say give me the total force on all 20 faces in the z direction added up, it's really close to giving me a number for what the drag is going to be on that object. So I have a very simple way of comparing performance of different structures. Okay, so if you've got all of the settings that look just like this, you're in good shape. Say evaluate, and we just come down with a single number, and we're almost negative 10 newtons. So what this is saying is that if this vehicle, as simple as it is moving at 5 meters per second in the forward direction, it's going to experience a force of almost 10 newtons in the other direction. So that's going to be pulling against it and degrading the performance of the vehicle. Now, these numbers are going to get better as we go through and spend more time with this analysis and get a better mesh and get a better convergence and all those other things that we'll talk about. But what you have now is a way to go through this process using AIM and come up with some quantitative values to compare and trade different types of designs. So have fun doing it.